Okay, so today we're going to take a look at the third method of solving systems. And this one is elimination. So you're probably going to want to have open the Desmos graphing calculator and the Desmos scientific calculator because we're going to make use of both. We're going to use the Desmos graphing to help us with solving this first problem. And then we're going to make use of the calculator to finish this rest of us up. So when we're talking about elimination means we're going to get rid of a variable and then solve for x and y. And I think as far as solving systems, this is the easier method of solving systems algebraically because it does allow us to have very simple two-step equations or even one-step equation to be able to solve them. It takes a little bit less work. We just have to find common multiples of numbers, and that's not too bad. Okay, so let's go ahead and start with our do now today. We need to come up with some equations based off our scenario. So we have the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 220 people enter the fair and 550 is collected. Okay, so we need two equations. Well, so I see that I have money, money, and money. So that is obviously everything is connected there. That is one of my equations. So I have $1.50 x plus, because remember, x is going to be child, because that's the first one I run across, and y is going to be the adults. So 150 or $1.50x plus $4 y is going to equal 50/50. Okay, so there's one equation. My second equation has to do with people. Well, so what kind of people came to the fair? Well, I do know that X is children and Y is adults. So if I don't have any other numbers given other than a total, my equation is always going to be X plus Y. Okay? It's always going to be X plus Y if they don't give me any other numbers. So this one's pretty easy. I know Y is going to equal negative X plus 2200. All right, so we need to do a little tweaking here on this to be able to come up with our y equals. So I'm going to subtract my 1.5x. And I have 4y equals 1.5x. And notice I'm going to go ahead and drop my extra zeros and my decimals on the 4 because I don't really need those at this point. I'm going to divide by 4, divide by 4. And I'm going to go ahead and leave these as fractions, even messy fractions, because my calculator, my Desmos graphing calculator can handle that type of equation. Okay, so I'm going to go ahead and pull up my Desmos graphing here. And let's pull in these equations. So let me get this pulled down here. All right, so my first equation was y equals negative x plus 220, 2200, I should say. And the second equation is y equals, and I better look at that again since my screen is a little bit bigger. I've got negative 1.5 over 4. Negative 1.5 divide 4. There's my x. And I had plus the 5,500 divided by 4. So I'm going to leave that just like that. Okay? All right, so we're looking for the point of intersection. Well, obviously I'm not seeing anything. Why am I not seeing anything? Well, I'm at 0 and I'm counting my 50s and I'm supposed to be up in the thousands. So I'm going to go ahead and shrink this in until I can see my graph. And I'm going to click and find my intersection. So where do we think our intersection is? It says 1320 and 880. 1320 and 880. So let's go ahead and think about what that means in our context. So 1320, 880. What does that mean? What are those numbers? Are those apples and bananas? Nope, you're right. The 1320 is how many children? attended the fair. And the 880 is how many adults attended the fair. So there was 1,320 children that entered the fair on that day, and there was 880 adults. Okay, so that's a quick little review from the graphing stuff we just did over the last couple days. Now let's move into substitution versus elimination. So substitution, we know that means replace. We're going to replace something with something else. So if I gave you 2a plus b and I said a equals 3 and b equals 4, then the 3 would go here and the 4 would go there. So we're just replacing. But elimination means to get rid of. Okay, to get rid of. So we're going to eliminate using inverses, which are the opposites. Okay, so like if I said up, opposite would be down. If I say positive 5x, you know the opposite is negative 5x. And if I give you a negative 3y, you know the opposite is positive 3y. So we are going to be looking for the inverses or the opposites. Okay, because somehow we have to get 0. All right, so let's take a look at our vocabulary. So the equation should be in the form of standard form. So we should have ax plus by equals c. That makes things easier because things need to line up. Okay, so the x's have to be over the x's, the y's need to line up, and the numbers need to line up because that helps us find the inverses. And the goal is going to be to eliminate one of the variables. Okay, eliminate one of the variables, and we're going to be looking for those additive inverses. That's what those inverses are called, additive inverses. Okay, so if I give you negative 3x, the additive inverse is the positive 3x. That's how I can cross those out and make a 0. So some of this looks very similar to what we do when we solve equations. All right, so here's our first problem. Okay, we've got 5x plus 3y equals 30 and negative 2x minus 3y equals 3. So there's a couple things that we do as we solve down here. So there's actually 5 steps. The first thing we're going to check is to make sure that things are lined up and that they're in standard form. So are the x's lined up, the y's lined up, and the c's lined up? Is it in standard form? Ax plus by equals c. Yes, they both are. Okay. Then I'm going to check and see if I have additive inverses. If I don't have them, I may have to multiply. But in this case, I have a 5 and a 2, and then I have this positive 3 and negative 3. Those are additive inverses. So I'm going to box my additive inverses. Okay, I'm going to box my additive inverses. Then what I'm going to do is I'm going to draw a line, and I'm going to add down. Okay, so 5x minus 2x, that's a 3x. And hey, these additive inverses, they're gone, so I've crossed them out. And 30 plus 3, remember we're adding, 30 plus 3 is 33. I'm going to divide by 3. So x is 11. Simple. I already have the first number in my solution. Okay, now to find my y variable, I am going to pick either equation, either one. And I'm going to substitute. So I think I'm going to pick the top equation because there's no negatives. So 5x plus 3y equals 30. And I know that I have x, so I'm going to substitute in for the x. And I'm going to solve for y. So 5 times 11 is 55. And I'm going to subtract my 55. So I have 3y equals, well, negative 55 plus 30 is going to bring me to a negative 25. And if I divide by 3, y is going to equal negative 25 over 3. And I'm going to go ahead and I can leave that as a fraction as long as it is simplified. I can also change that to a decimal if I want, because it is an ordered pair. And it's easier to find that on a graph if it is a decimal. So that would be 11 and negative 8.3. Okay, let's try another one. All right, so are they in standard form? 2x plus y equals 9, 3x minus y equals 16. Yep, that worked out pretty well. So they are in standard form. So now I'm going to look for additive inverses. Do I have opposites? Well, look at your x's. Are those opposites? Nope. The y's are opposites this time. So I am going to box them and cross them out because they are gone. I'm going to draw a line and I'm going to add down. 2 plus 3 is 5. 9 plus 16 is 25. Divide by 5. X is going to equal 5. So I have my first part of my answer. It's 5. Okay, again, when I'm solving for the second part to find my second variable, it doesn't make any difference which variable which equation I pick. I like to pick the one that has the least negatives, so I'm going to use the top one. So 2 times 5 plus y, that is a 10. I subtract my 10, and I come up with y equals -1. And there's my answer, 5, -1. So you can see how sometimes these will work out to integers, and sometimes they're going to be decimals. Okay, sometimes they're going to be decimals. Okay, let's look at this next one. Well, this is interesting. They're already in standard form, but what do you see? Well, I see that I have additive inverses right here. So if I cross those out and I add down, -6 plus +6, wait a minute, that is a 0 and a 0. Well, what does that mean? Okay, I want you to think back to the other two types of solving systems that we had. We have our one solution, which is normal. We have parallel lines, and we have the line that are the same, which was the infinitely many solutions. Well, which one is this? Is this parallel where they don't touch, so it's a no solution? Or is this an infinitely many? If you said, hey, that's an infinitely many, I hope you realize that 0 equals 0, and that is a true statement, okay? If I would have come up with 4 equals 0, I know that would be false, and that would lead me to a no solution. So we will get some of these where the x and the y's will eliminate, and we will come up with a no solution or an infinitely many. So pay attention to that as you're working. Okay, let's keep going. All right, so take a minute, hit pause to kind of get your head wrapped around additive inverses and kind of look at this for a second and think about the additive inverses. Okay, so hopefully when you're looking at these, you're realizing that I don't have additive inverses yet. I have the same. Okay, so these guys are the same. I see that I have the same numbers with the y's, and I have the same numbers here with the y's. Well, if I add those, they're not going to go away. They are not additive inverses. Okay, so what I need to do is I need to make additive inverses. Well, how do I make additive inverses? Think about how we changed our standard form to make a positive. We multiplied by a -1. So what I'm going to do is I'm going to pick one of these. I'm going to multiply by -1. I'm going to go ahead and write this beneath it. So -8x, -1y, and a +16. So now this guy's gone, and I actually have my additive inverses here. So go ahead and at this point, hit pause and see if you can finish solving this problem. All right, let's see how you did. So if I add down -3x, -8, and -5 plus 16, that's 11. X is going to equal -1. Okay, so I have -1. All right, so it doesn't make any difference which equation I use. I can use the one I crossed out, the second one, or the third one. It doesn't matter. I'm going to go ahead and use the second one just because I can to mix it up a little bit. The -1 is going to go in here with the x. So -3 times -1 is +3. And I subtract my 3. Y is going to equal a -8. So there is my solution. All right, go ahead and hit pause and start working on the second problem on this page. Make your additive inverses. Remember, you need to multiply one of the lines by -1. Okay, let's see how you did. So if I multiply one of the lines by -1, that gives me a positive 2x, a positive 9y, and a positive 25. And again, this guy is kind of gone. I don't want to get mixed up by looking at that one. So I'm going to cross it out. Here are my additive inverses, and I can go ahead and solve. So -4 plus 2, that's a -2x, and -23 and 25, that's a 2. So x is going to equal -1 again. And let's substitute back in. So I'm going to go ahead and use this one here where it's positive. So 2x plus 9y equals 25. Drop in my -1. So -2, 9y, 25, subtract my 2, 9y equals 23. So y is 23 over 9. Okay, and the decimal for that would be 2.6. So -1, 2.6. Okay, let's take a look at one more type of problem when we're coming up with elimination. So this is one where we don't have even the same numbers. So we're going to have to do some multiplication. Okay, we're going to have to do some multiplication. So let's take a look at our numbers here. So I have a 6x, a -12y, a 24, a -x, a -6y, and a 4. So the easiest thing to do is find a 1x or a 1y. That's the best thing to do, okay? And that will give me something to multiply easily to be able to create that additive inverse, okay? And we'll talk about the second one in a minute where we actually have no 1x or 1y. So I see that here I have a -1 right there. Well, I see that I have a positive 6 here, but I really need a -6 if I'm going to cross those out. What am I going to multiply this by to make a -6? Yeah, I'm going to have to multiply by 6. And remember, I have to multiply everything. So 6 times -1 is -6. 6 times -6 is a -36y. And 6 times 4 is 24. I'm going to go ahead and rewrite this top equation again, just because it'll be a little less messy for me. I'm going to find my additive inverses. Oh, there they are right there. And I'm going to cross my x's out this time. And I'm going to add down. So -36 and -12, that's a -48y. 24 and 24, that's 48. I see y is going to be -1. Now keep in mind this is y this time. So it's in the y value, not the x value. Okay, and I'm going to go ahead and use equation number 1, because that's the one that I have not messed with, to solve for x. So 6x, -12 and -1 is positive 12. Subtract my 12. I come up with 6x equals 12, so I know x equals 2. So there is my solution for that problem. Okay, now, what happens when I don't have a single x or a single y? Well, I'm going to think about multiples, okay? I'm going to look at my x's and look at my y's and try to figure out either a number that I can multiply one line by, or sometimes I actually have to multiply 2 lines. And in this case, I'm going to have to multiply 2 lines because I can't make a 3 a 5 and I can't make a 2 a 3, okay? But I certainly can come up with a least common multiple that both of them can be multiplied by to create a whole new set of equations and additive inverses. So we have to decide at this point, do we want to get rid of x's or do we want to get rid of y's? Well, I think we should get rid of x's because I know that 3 and 2, if I multiply them, could make a 6. So if I need a 6x on this first one, that would mean I would need to multiply by 2. So 2 times 3 is 6. 2 times -5 is -10, and 2 times -14 is a -28. Okay, so if that's a positive 6x, I know I need a negative 6x on this bottom one. So if I already have a -2, what am I going to need to get a negative 6x? Well, this is going to be division, okay? When you're trying to figure this out, if I need a negative 6x and I already have a -2, what is -6 divided by -2? That's a 3. So 3 times negative 2 is negative 6. 3 times 3 is 9. And 3 times 10 is 30. Okay, so there's my additive inverses. They are gone. So a negative 10 and a positive 9 is going to leave me with a negative 1, and I have a 2. That gives me a really easy answer of y is negative 2. Okay, so I'm going to go back up and use my original equation. Now I can actually use any of these 4 to be able to solve for y, but I like to use one from one of the original ones that I haven't messed with. So 3x minus 5 times the negative 2. So I have 3x minus or plus 10 equals negative 14. If I move my 10, I have, oops, let me get back to where I was here. I have 3x equals negative 24. Dividing by 3, I come up with x equals negative 8. So there is my solution. I have a negative 8 and I have a negative 2. Okay, so that is elimination. Go ahead and give things a shot today. Reach out to us if you are stuck. We're going to work some more on this for a couple of days. So I'll see you tomorrow on the video.